This day, I will be talking about transformation of parabolas, that is analyzing the effects of a, h, and k and deriving the equation of a parabola given a certain condition. Firstly, we have this what we call parent function denoted as f of x is equal to x squared, where the vertex is at 0, 0. Basically, this is just a simplification of a equal to 1, h is equal to 0, and k equals to 0. Remember that the vertex of this function is at 0, 0. And then x minus 0, to simplify this, x is minus 0 is x squared, and then no need to write the plus 0 and the 1, because that is understood to have a 1. Now, the vertex here has its origin with a is equal to 1. Now, I want you to watch this video and notice about the effects of k in the parent function of x squared. So, the next video will tackle about the effects of k, where we will change the value of k from -5 to 5. So, observe that as k grows bigger from 0 to 5, the graph moves up. And then, as the k moves to -5, the graph also moves down. So notice here in the sliding function, in the slider function in the left side, so we have k is equal to 0.325. That means if we increase the value of k, or we put a positive value of k, the graph will move blank units upward. Example, I have y is equal to x squared plus 3. Since the parent function has the vertex at 0, 0, here we have a 0x, a 0h, and 3k. So the graph will move 3 units upward. So the vertex will be at 0, 3. That's it. If positive 3, the graph moves 3 units upward. But on the other hand, if it's -3, x squared minus 3, the graph will move 3 units downward, or 3 units below the origin. Remember that the origin is the intersection of our x and y axis. The coordinate of the origin is 0, 0. I want you to observe the effect of the graph, the effect on the graph if we change the value of h. H is the x coordinate of the function. So as x moves, or as x moves toward the negative value, the x moves to the left. And as h moves to the right, the graph moves to the right. The h is positive. Sorry. Now, that means if h has a negative value, the graph moves to the left. And if h has a positive value, the graph moves to the right. But take note, in the graph, or in the formula, y is equal to x minus h quantity squared, h here is negative. That means if we are given with y is equal to x minus 3 squared, it tells us the opposite. Since it is -3, the graph moves 3 units to the right. Okay? There is a certain change in h because of the negative in the formula. So again, if the formula, if you're in the vertex form, and then h there is negative, the graph moves blank units to the right. Here it's 3, so 3 units to the right. There's no k, so our k is understood as 0, and our h is 3. So if we have y is equal to x minus 3, the graph moves 3 units to the right. Though it's negative, but the formula uses a negative value. On the other hand, if we have y is equal to x plus 3 squared, it's plus 3, it moves 3 units to the left. Remember, there's a change if we are using the vertex formula. Plus 3 units to the left. Now, let's go to A. Try to observe the effect of A on the graph of a quadratic function. What will happen if A is greater than 1 and A is greater than 0 but less than 1? Okay, we all know that if A is less than 0, that is A is negative, the graph moves or the graph opens downward. If A is positive or A is greater than 0, the graph opens upward. But let us see what is the effect of the graph if greater than 1 or greater than negative 1. So we have here A is equal to 1, and then that's it, that's a parent function, and then we will change it into 5 to negative 5. So if it's a negative value, the graph moves below. And as you can see, the bigger the A, the narrower the graph. So if we will make our A bigger, like to 5, to 6, the graph will become narrower. The bigger, the narrower. And then the same also if negative. The bigger the negative value, the narrower the graph. The smaller the negative value, the wider the graph. Okay, so since 1/2 is lower than 1, smaller than 1, that means it is wider than the parent graph. If it's 1/2. 1/2 is just 0.5, right? Now, let's see the combined effects h and k on the graph of a quadratic function. So I am now turning on A, H, and K. To summarize, if A is positive, the graph opens upward. If A is negative, it opens downward. If A becomes bigger, the narrower the graph. If A is smaller, the wider the graph. If H is negative and in the formula it is positive, the graph moves blank units to the left. And if H is positive or in the vertex form it is minus, the graph moves blank units to the right. And then if K is positive, the graph moves upward because K is Y, right? Y coordinate. So it is safe or it is correct to say that the graph moves upward, the movement of the y-axis, and K is negative, it moves downward.